Hi, Bobby. Can you hear me?
Yeah, I can. Can you hear me?
Made issues today, just so you know. So happening. Hopefully my internet will hold up. See how it goes. It's been a crazy morning. Good morning, everyone. I hope everyone else's internet is doing. Mine is really struggling this morning. I don't know what the deal is. But I didn't have time just to reboot the whole thing, right? That would have taken long. So hopefully we'll make it.
Good morning.
Good morning. All right. So happy Monday. Have test week. I know that's exciting for everyone, right? I know.
Yeah.
I know. I thought so. Everybody's excited. All right. I am going to play a short video for you guys that is about test anxiety and math anxiety. So we'll see. It's only 2 minutes, so you should be fine. And then we'll talk a little bit about the test, and then we will start talking about Z-scores, okay? Okay, now it'll take me a minute to get it ready again. So hopefully you guys can hear it. Please tell me if you cannot.
It's normal to feel anxious before a test, presentation, or when you are writing a paper. You might feel anxious, jittery, testing. Afterwards, you might leave feeling wiped out and feeling certain you didn't do well. Your mind might go through the test over and over, rehashing all of your answers. Experiencing this anxiety may leave you feeling like you didn't have a fair opportunity to demonstrate everything you knew on the test, and that can be frustrating. Dr. Cian Beilock, in her book, Choke, talks about reasons why test anxiety can get in the way of our performance. When people start to worry excessively, it robs them of brain power, particularly working memory. Working memory is like your personal post-it note. We stick information on it for temporary storage while we are working through an answer on a test. But when we experience test anxiety, our mind can get clogged up with worries. Worrying triggers our fight or flight response and a cascade of stress hormones, which further compromise our abilities to read and respond to the exam in a calm way. The good news is that there are brief interventions you can do before and during a test to increase your performance. Interventions that target our stress response, like meditation and breathing exercises, can decrease the negative impact of worrying on our brain. In one study by Beilock, students raised their exam score by 5 points just by meditating for 10 minutes before the exam. Want another way to reduce stress? Write it down. If you take a few minutes to write down your worries and fears before an exam, it'll help clear them out of your brain and free up space to focus. Finally, reflecting on your values and important roles outside of your academic performance can help you remember that while this exam may be important to you, your life is infinitely bigger than just this test. So take a few minutes and try each of these ideas before your next exam. Research has shown students have boosted their performance by a letter grade after using them.
All right, so I don't know how much of that video you could hear because the ding dong is going on, right? Ding, 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 people coming in. Oops, hold on. If you can still hear things, but I still can. All right, so could anyone hear the volume on that video? Yeah? Okay, so tell me, get one idea in mind got from that video that you could use. So ready in the chat, and then we will do a 3, 2, 1, okay? So get one idea from that video ready in the chat, and then we'll do a 3, 2, 1, go. All right, 3, 2, 1, go. Excellent. I'll make sure these slides are posted so you could watch that video again in case you came in late or you just couldn't quite hear or whatever. So yeah, meditation before a test. Did you hear what they said? How long should you meditate before you take the test? Did they give a time? Yeah, 10 minutes. So, and what did they say about that 10 minutes of meditation has proven to improve your grade by how much? Yeah, 1 letter grade, which was crazy. I'd love to look at the research on that. That was from Northwestern University. So 1 letter grade, a lot of you could probably use that. So Zevi put in a great one. Write it down, the negative thoughts. Those negative thoughts are creeping in your head. If you write them down before you take the test, you can get them out of your head. So then you can really focus. Did you notice that it said when you start to worry, it robs your brain of the power to solve the problems, and it robs your brain short-term memory. And our short-term memory is like that sticky note you have there where everything on it. So a lot of you might have felt that before. I love that Clementine also said good things about yourself to remind yourself that this is not the end of the world. That is super important. If you know that going in, you'll be able to keep your stress level low. Breathing beforehand, excellently. Write down what you think you'll do wrong. Very nice. You guys have some great things, and that was literally a 2-minute video. So if you really struggle from anxiety, especially math test anxiety, you should start practicing now for your test on Thursday, right? Your environment's going to be a little different than it normally is in a face-to-face classroom. So hopefully you can provide the environment that's best for you. You should be in a quiet space with no distractions. It should be well lit, and you should be ready and prepared for your exam, right? And you should be ready. You shouldn't wait until right at 9, to get your computer started, right? You should have your computer up and running and ready to go. And then when that test opens, you can just start and you won't be panicked about, oh, did I download the lockdown browser, right? All of those things. So make sure that you take that extra time for yourself, okay? Because it is a timed test. It's gonna time out on you. Okay, so Bobby, this would be a great time, I think, for you to talk about your review session.
So the review session for Roxanne's classes and our class, if she extends it to another section, maybe some more people in her other classes might join us on Wednesday between 2 and 3 p.m. in my Cranium Cafe. I'll be sending a message out the same way I sent the poll out to your Canvas email, and it should include the link for you to join me. This is the first time I'm using my Cranium Cafe for a review of this magnitude in the classroom setting. So be a little bit forgiving with me if things don't go as smoothly as they do here with Roxanne, but hopefully we'll still be able to do all of the similar things that we've done in the tutoring sessions and working in here in Zoom, even though it's a different program. Make sure that when you join the cafe that you're using either the Chrome browser or Firefox. Don't join in the Safari, so Mac's default browser, or Edge. I've had some students have recent problems with Microsoft Edge browser too. So just stick to those two and you should be able to join, no problem. We can set up little breakout rooms. We can work in a whiteboard space. And I largely let students dictate what questions we cover. It doesn't make a lot of sense to me to cover questions nobody struggled with or nobody had any questions on. So if you can come with a few questions of your own that you'd like answered, that'd be great. If you want to just come and watch and listen, that's also great. It's up to you, but it will be Wednesday, again, Wednesday from 2 to 3 p.m.
Excellent. Thank you, Bobby, for providing that. And if for some reason you can't go Wednesday between 2 and 3 p.m., the tutoring center is open, right? So you can go to the tutoring center anytime. Some of you did a great job on your tutoring assignment, really connecting with the tutor. I had a variety of tutors that were connected with, so that's awesome. Some of you connected with Brainviews instead of our MCC tutors, which is totally fine as well. Just know that our MCC tutors are also available. So it totally depends on, what you need. We'll also be reviewing in class on Wednesday. So that'll be a great way for you to go, I still don't know this, right? And so that might be a good opportunity for you to send a message to Bobby even before the meeting that says, I still can't do number 8 or whatever it is. I don't understand it. Can we do a problem like that? So you can give Bobby some time to find a problem and just trying to make one off the top of his head, because that's really hard. And if it's a more question, you have the more questions. If it's not on the review sheet, you probably don't need to super stress about it, right? Because the review sheet is going to be really important to help you with the test. Can you see me frantically looking around for my Apple Pencil? I can't find it, and I might have a little mini panic attack, but it's okay. I'll be fine. If I lost that, I don't know what I do, but I just made a video this morning. The story of my life, real quick, before today is last night, I stayed up real late making a video for my classes, right? Like at about, 11:30 p.m. I was making, and it was about a 30-minute video, and then had a processing error and didn't save. It was super fun. So then I got up this morning and made the same video again. This time it processed, so I'm super happy about that. But obviously it didn't get to my students when I needed it to, but that's okay. Live and learn. We will all focus. I seriously can't find my Apple Pencil. That is traumatizing. It's okay. Let me show you something. Oh, good. Did you guys like the video on the 68, 95, 99.7? Did that help you guys? I got your video out. So you guys were good. I got that one out. Okay. I'm going to just start on this problem, and you can just sketch it in on your paper or on a whiteboard if you're close to a whiteboard. We're going to see if all my tech is cooperating. I think I just said display my screen in the living room. We shouldn't do that. We're not going to do it in the living room. We're going to do it right here. So take a look at this. This is the Life of Sunshine DVD players. DVD players, that's funny, right? I still have one, just in case you're wondering. It's not a VHS player, it's really a DVD player. So is normally distributed. Remember what that means, normally distributed. That should give you some keys right there. With a mean of 4.1 years and a standard deviation of 1.3 years. So draw out the normal distribution, include a title and a title for the horizontal axis, include your units and labels, okay? And write out your data values. You don't have to write your z-scores, just write out your data values, because then we're gonna talk about z-scores. So try that, and I'm really going on the hunt for my Apple Pencil. I want to go out. Oh, sorry, that was me. There you go. All right, still can't find it. Super excited. I just made my video with it, so it has to be here. Like, seriously. How did you guys do? Did you label these things? Everybody understood what we were doing? Who would like to walk me through the labeling? Now, my drawing might be atrocious since I can't find my Apple Pencil. Any volunteers are going to walk me through that, huh?
What do you want me to do? I'll do it.
Follow these directions, right? Which is what you should have been
Okay.
doing already. So tell me what the title is. Tell me
For
what the
title,
horizontal axis. Yeah.
Okay. For the title, I did Life of Sunshine DVD players.
Okay. Pardon my handwriting. Okay.
On the left-hand side, I just, for my own reference, wrote down mu equals 4.1 and the standard deviation is 1.3. Just so I didn't have to keep looking up and digging through all the words.
Nice.
And then for the actual graph in the middle, right in the very middle, at the biggest part of the hump is where the mean is. It's 4.1. And then each standard deviation is 1.3. So if I'm going to the left, I'm going to be subtracting that from the middle. So I have 4.1 minus 1.3 is 2.8. And then I subtracted 1.3 from 2.8 and I got 1.5. I think I might have done my math wrong there. Give me 1 second. Yeah, no, they got 0.2 for the last one.
Okay. And the other way?
And then we go to the right, so we add it because it's on the right side. So 4.1 plus 1.3, 5.4. For the second standard deviation, I got 6.7. And for the third and final, I got 8. And then you have to label what these units are. So I did parentheses underneath and put years.
Very nice. Excellent, Andrew.
That's all I
Good
got.
job. So excellent. That's great. Now, so if you had a DVD player, a Life of Sunshine DVD player, the mean of 4.1 is telling you it should last about, on average, just over 4 years, right? But if you're me, you probably bought this DVD player, right? You got the lemon that only lasted 0.2 years, right? So it only lasted like a couple months, right? Not that great. So, or if you were the lucky one, maybe you got a Sunshine DVD player that actually lasted 8 years or over 8 years. Yeah, but most of them just lasted around the middle of that. So is everybody okay with that? Any questions? All right, let's talk z-scores for a minute. Dang it. So let's talk z-scores. So the empirical rule applies when a value is exactly 1, 2, or 3 standard deviations from the mean, but that doesn't happen very often. So we standardize things and we've called them z-scores. And it's the number of standard deviations a data value is from the mean. And we can plot z-scores on a special normal distribution called the normal distribution. This is very specific because if we call it a standard normal distribution, then the mean is 0 and the standard deviation is 1. Yes, always. So what z-scores do is convert your data into a standard normal distribution so it's easier to evaluate. So that being said, if you look, if your z-score is 0, that means it's exactly the same as the mean because it didn't go to the right or to the left at all. If your z-score is positive, then it's above the mean. If your z-score is negative, then it's below the mean. Okay, and then we're going to talk about how to calculate z-scores in just a minute. So let's go back to our Sunshine DVD place. So if we say we've made this now a standard normal distribution and we're going to write our z-scores underneath our other scores, I would write a 0 right there at 4.1. I'll actually change the color so it might be a little bit easier for us to see the z-scores. So a z-score of 0 would be the same or equivalent to the mean of 4.1. Then when I'm going to the right on this standard normal distribution, one standard deviation would be that value of 1, because remember, on a standard normal distribution, my deviation is 1. So then this would be 2, this would be 3. If I'm going to the left, I'm going to say -1, -2, -3. So this is connecting what we did on last Thursday with what now we're learning about z-scores. Any questions on those numbers?
I have a question.
Yes.
So with z-scores, it'll always be converted to 0, your mean.
The mean will always be 0. Yep.
Okay.
And we can talk about that formula and how we calculate z-scores in just a second. Any other questions?
Mine was just on the calculation, so it's fine with the
Okay.
calculator, not by itself. So
Okay, we're almost there. We're gonna go there soon. Okay, so there you go. There's a nice one without my finger writing. Okay, so now it's gonna ask us some questions. And notice that on this picture, I put the X values or the data values on top, and then I put the z-scores on the bottom. But let's just see if we can answer questions first. It says, how long does a DVD player last if its z-score is -2? So think about that. If its z-score is -2, how long does the DVD player last? We're going to get it ready in the chat. Okay, so get it ready in your chat. Okay, are you ready? 3, 2, 1, go. Very nice. 1.5 years. I love how a lot of you put your units on there. That's awesome. Good job. And how we did that was we just looked at our graph. That's why these drawings are very helpful to you, right? To figure out the problem. And we found the z of -2, and we just saw what that corresponded to on our graph. Now, let's talk about how long do 68% of the DVD players last, 95% of the DVD players last, and 99.7% of the DVD players last. So think about that for just a minute. I found it. You want to know where it was? It was a keyboard. Yes, I'm a genius. It was under my keyboard. You're welcome. I was a little panic attack for nothing. I hadn't gotten up 2 hours, so I didn't know where else it could be. I've been sitting here working, making videos, so who knows? Okay, so how about we just call on random people? Wouldn't that be fun? I mean, I'll let you volunteer. So somebody answer the first one. How long do 68% of the DVD players last?
I got 1.5 and 5.4 years.
Okay, so between 1.5, you said, Maddie? 1.5, and what was your other?
And 5.4.
And 5.4. So let's
Oh, you
take
know
a
what?
look.
It's 2.8. I'm sorry.
There you go. I was probably because all my writing was in your way. 2.8 years. Very nice, because it's one standard deviation. That's 68% of our data. So between 2.8 years and 5.4 years. Excellent. Next, who's going to do 95%?
I can. So
I'm
for
ready.
for 95%, it was in between 1.5 years to 6.7 years.
Nice. And I want you to think about that. So 95% of the people who bought Sunshine DVD players were in that range. So their DVD player lasted between 1.5 years and just over 6.5 years. Does that make sense? I'd like you to talk in terms of the problem so it makes sense in your brain. All right, so on that one, this one was this second line, right? And then how about that last one? The how long do 99.7 of their DVD players last?
I can do it.
I'm ready.
So it's between 0.2 and 8 years.
Very nice. Was that Jonathan?
Yeah.
That's awesome. Good job. I know almost everybody's voice. I'm so excited to people who talk to me. Good job, Jonathan. All right. And so that was within 3 standard deviations. All right. Now the next question if you were doing your homework, maybe you could answer, but we're going to talk about it more specifically. So how would the z-score, what would the z-score be for one of the DVD players that lasts 6 years? If we come up here, we're going to look at these X values for 6 years, and we can tell that 6 years would be in between these somewhere, right? Does everybody agree that it would be in between there? So my z-score must be between 1 and 2. Is everybody okay with that? I didn't give the exact z-score yet. I just said, oh, it's going to be between 1 and 2. Any questions on how I got that? I didn't find the z-score exactly yet. Okay, because I didn't tell you the formula for a z-score yet. So the formula for a z-score is z equals, you take the data point minus and divide by the standard deviation. So that's how we find it. Let me show you. I have a better explanation on this one. There you go. X minus the mean divided by the standard deviation. So that's how you calculate the z-score for any value. So now using our value, 6 years, right? So that would be our X minus our mean of 4.1. And then we're going to divide it by our standard deviation, which was 1.3. Use that formula and let's see if we can find the z-score. Be careful on your calculators. Some of you might need to go like that in order to do it, okay? And then get it ready in the chat and we'll do a 3, 2, 1 in just a minute, okay? Oh, you guys are already chatting it away. Good job, Ben. Are we rounding? I didn't state we're going to round yet, but we're going to talk about rounding. Because this is repeating decimal, right? Okay, so if we rounded to the nearest hundredth, let's do a 3, 2, 1 chat. Yes? 3, 2, 1, go. Very nice. A lot of you had it ready, I can tell. So if we were going to the nearest hundredth, that would be 1.46. And Clementine, you're the one. So Clementine, what's interesting is this is years. So it's not any more years because now we're on z-scores. Z-scores aren't necessarily the same units that we had before. So it's a little weird. Our years simplify and our z-score is just a number. So, but what's interesting is if we look at this picture, we kind of could tell that our z-score was in between 1 and 2, but that's how we specifically found the z-score. Everybody okay? All right. Let's take a look. There we go. Now, this is the part we haven't gotten to yet, right here. Do you see how it says a z-score of 1.5 would have an area of 0.9332? And some of you are like, what are we talking about now? Okay, so z-scores are helpful if we're trying to find the area under the curve. So, and you have a z-table. So if we're finding the area under the curve, we're finding all of this area. Think about that. Do you see how it's 0.932? If we change that to a percent, that would be like 93%. So we have 93% of our data under this curve right here. We're going to look at a z-table in just a second. So just keep that number for you in just a second. Here's our z-score table. Now, if you notice our z-score table, and you have access to this, goes from -4, and then it goes all the way up to 4. And this is just a little abbreviated. Now, notice it says all values are the area to the left of the specified z-score. So you see how I shaded that area to the left? If I want to find the area to the right, I have to do 1 minus the area to the left. So when we calculated our z, we got 1.46. But if I look at this table, I don't have to the 100th. I only have to the 10th place. So I have to decide, do I want to use 1.4 or do I want to use 1.5? Well, rounding would say I'm going to use 1.5. That's where that 0.9332 came from. So if I said, what percent of the DVD players last 6 years or less, my answer would be 93.32% would last 6 years or less. If I said percent lasts more than 6 years, I want the area to the right. So I would have to do a calculation where I take that 1 minus 0.9332, and I get a value of 0.0. Now my battery's almost dead on my Apple Pencil. What is happening to me today? See what happens when you stay up late and make videos? You forget to charge your Apple Pencil. I don't think it'll let me write when it's charging. Let's see. And when we subtract that, we would get, nope, won't, 0.668 is to the right. So about 6.68% of the Sunshine DVD players lasted longer than 6 years. So remember
0.0668,
oh,
right?
Sorry. Yes, sorry. Thank you. Oh, I can't use my Apple Pencil. I should have just kept it lost. Yes, so then it would be 6.68% would be to the right. So I'm going to go back to this picture so you can see it. Remember how I had this picture? So when I found that 0.9332, That was from the table when I looked up 1.5 as my z-score. So that's that area shaded to the left. If I subtracted 1 minus that 0.0668 would be the area to the right. And I know this is hard, and this is the last idea in here. So that's why we're just going to do more practice. So I'm going to pause there and see if you guys have any questions.
Where is that table accessible? The z-score table?
I'll put a link for you. It comes up in more all the time when you need it. There
Okay.
is a review sheet. So
Okay.
it's on a formula sheet. I'll make sure I show it to you.
And that'll be available for our test as well?
Yeah, it comes up in more in the questions.
Okay.
So yes,
So
on the test.
Sorry. So for the test, are we going to have to use the Z table, or can we use our calculator, because our calculator populates something else?
Good question. Yes, and we'll talk about the calculators. I'll have to look back at your test and see. I'm sure I allowed either one.
Okay, cool.
Okay. So yes, Kate, Bobby put a great answer in there. What do those percentages mean? Remember, if we go back to this whole curve, we know 100% of our data is under that curve. So when I mark it off with a z-score, then I can say, okay, what is the area to the left of the curve and what is the area to the right of the curve? So that's what those data points represent, or those decimals are percentages.
Will you always start on the left side, I guess?
It depends on what the question is that it's giving you, right?
And tell me again,
So-
how can you tell the difference of like which side you're gonna start on? Like if like this question says the z-score of 1.5 would have an area of 0.9332. Like what would be how would you know if it's gonna be on the right side, I guess?
Yeah, because it's going to tell you less than this value or more than this value. And the table is automatically set up for less than that value. And if you want more than that value, you have to do 1 minus that.
Okay, thank you.
And we'll see an example too. Okay. So if we look at this right here, if we have a data set that has scores on a standardized test, some of you might have taken the SAT or the ACT or the PSAT, those kind of things. Those are, or in elementary school, you take the NWEA sometimes, you take different standardized tests. When it says standardized, this is what it means. It means normally distributed, okay? So if we have data on a standardized test where we have a mean of 510 and a standard deviation of 95, the question, and Maddie, this is exactly what you were talking about right here. How do I know? It depends on the question. It says what percentage of students scored less than 650 on the test. So it's going to have a keyword there of less than. Okay. So we know, since it's a standard distribution, that I'm going to put 0 for the mean, and I'm going to put my lines of 1, 2, 3, and to the left, -1, -2, -3. And first, we're going to calculate the z-score that corresponds to this test score of 650. So we're going to take 650 minus our mean and divide it by 95. When we do that, we get 1.47. Okay. So I think that part's okay. Is everybody okay with just calculating the z-score? Because then the hard part is the interpretation of the z-score. Okay. So when it says, this tells us the percentage of students who scored less than 650 on the test will be equal to the percentage of observations that are less than 1.47 under the standard normal curve. Okay, so we could look at our data, at our table again. We're going to that same point. So notice this is a different application, but it uses the exact same z-score. Okay, and it gave us the area from the table as 0.9332. We make it a percentage by multiplying it by 100. So we can say that approximately 93 and change percent of all test scores were less than 650. And since we knew that percentage from before, if they reversed the question and said, what percentage of test scores were above 650, we would know that's 6.68%. Does that help you a little bit see an actual example? Okay. This is just an explanation of this area. So it says, if the area to the left of X in a normal distribution is this, 0.123, what is the area to the right? How would you figure that out? So what it's saying is if the area to the left of the whatever data point they tell us is 0.123, how would I find the area to the right of X? Think for about 10 seconds, and then I'll ask somebody to help explain if they can. All right, nice. I like you guys using the chat. So if I know that the area to the left is 0.123, then the area to the right must be 1 minus that. And right now, we don't have any information on what this data is or what it means. It just wants us to figure out, understand the curve. So if we know that, then we know the difference is 0.877. Okay, how about the second one? If the area to the right is 0.4543, what is the area to the left? Okay. I see in the chat, you guys, we don't need the table for this because we're still doing the same thing. It just told us what the number from the table was. It's telling us that the area to the right is 0.543. If I want the area to the left, I'm just going to subtract. Because if I know these sum to 1, if I have one of them to find the other, I'm just going to subtract. So you should have gotten 0.457. I'm trying to find my link to my standard Z table for you, your formula sheet. So let me find that real quick and I'll put it in the chat. All right, so there's actually your formula sheet. that you're able to use on the test, but I've built it into more. So yeah, you could picture it with shading. I just didn't want to shade it wrong because it's a little questionable. So this one right here, the area to the right is 0.543. That must be about here because all this area, there's 50% of our data in the middle, right? So then that must be a little more than 50%. So it would be a little to the left of that. So that would be your 0.543. And that means this part over to the right would be that 0.457. Like on this first one, it said the area to the left is 0.123, so about 12%. So that would be about here, right? Ish. So this part would be our 0.123, and all of this would be our 0.877. So yeah, you can use that shading if that helps you. Yeah, the second one is much easier to picture, I think, than the first one.
Okay, I get this portion of this, but where are you getting 1? I'm really trying to wrap my brain around it. I don't know if it's because I'm tired, but like
100%.
Oh.
Right? 100%
Okay.
is this whole curve, which is a total of 1. Remember, 100% is the same as 1.
Okay. Cool.
Yeah. So it might help you if you think of them as percentages instead. That might make more sense because 100%.
Thank you.
Okay. Yep. There's my answers. So this one might be a little bit harder for us to do. We might need to do a little bit. Well, let's see if we can start and make sense of this problem. So when you first look at this problem, a variable is normally distributed with a mean of 84.6, a standard deviation of 19.1. Find each of the following. Draw the associated normal curve, shading the solution region. So we know some things. We should be able to label, we should be able to label right here our X values. So can anyone tell me what number would go right here in the middle?
84.6.
Very nice. How'd you know, Leslie?
Because it's the mean.
Very nice. If it's right in the middle, it's going to be the mean. Oh, I just wrote 5. 84.6. Very nice. And then if you have the spaces to the right, we're going to add this 19.1 to it. Let me see if I can write that a little bit better. So we have 84.6. And so we're going to add 19.1. Does everybody know why we would add 19.1? Because that's 1 standard deviation. That space must be 19.1. So I get 103.7. Yes. And then you're going to keep going. Label all of those. And then the next thing you want to make sure you notice, just for peace of mind, these are our X values. Then we have our Z scores. Let me put our Z scores. And the Z scores are much easier because the Z scores are just 0, 1, 2, 3, and -1, -2, -3. So if you start making your own pictures, it's really going to help. How would I find the numbers on the left of the mean?
You would deduct 19.1 from the mean.
Very nice. So instead of adding 19.1, we're going to subtract 19.1. So we're going to 65.5 and then minus 19.1. And we get 46.4. And we subtract 19.1, we get 27.3. Okay. this just gives us a general idea of how things are working, right? It's not necessarily giving us the answer, but it's helping us make sense of the problem. Okay? Any questions on what we did? Yeah, Bobby brought up a good point. He draws the bell curve on all of these problems and label the X values and the Z scores, just like we're seeing here. That's a great way to make sense of the problem, right? So good job. Thank you, Bobby, for saying that. Okay, so now we want to find the area to the left of 60.5. Okay, to the left of 60.5. Well, is 60.5 one of my numbers on my label already? It's not. So I need to use the z-score formula to find the z-score. So remember, the z-score formula is x minus the mean divided by the standard deviation. So let's find the z-score first. And some of you might be thinking about it already when you plug it in and you're like, oh, 60.5 is smaller than 84.6. So I'm going to get a negative value here. Yes? Okay, and let's go to 2 decimal places. So let's get it ready in our chat for our 3, 2, 1 chat. Yes? Don't forget your negative sign. 3, 2, 1, go. Very nice. Negative 1.26, but that's not our answer, right? That's just our z-score. How do I find the answer now?
You're going to need to use the z-score table.
Very nice. So if we use our z-score table and we go to negative 1.2, now notice that on our z-score table, it's either negative 1.2 or negative 1.3. So which one do you think you should use if you have negative 1.26?
1.3.
Yes, you should use negative 1.3 because of our rounding rule. Excellent. So we would use this one. I highlighted all of them. So now I have that. Yes, 0.0968. Good job, Francisca. So now I'm going to answer that. And I'm going to say 0. Oh, I'm going to say 0.0968. And if you look at your picture over here, 60 would be about right here. And so there would be kind of a small percentage over here. This is really like 9.68%. Now, could I do this next one pretty easily? Because the next one says find the area to the right of 60.5. I don't need to go back to the Z table. I don't need to do that. How would I do that part?
I'm sorry.
You would take 1 minus 0.0968.
Yes, because we would be looking for this part of the curve. Okay, and so for an answer, what did you get? Is that what you got? 0.9032. All right, I want you to try those next 3, and you can chat with each other. You can chat with Bobby. You can chat with me. Try those next 3, and then I'll reveal the answers, and we'll go over any of the ones you don't understand.
to the left would be
All right, since I'm giving you several problems to do, I just wanted to give you some time. But when you're done with all of those problems on that page, can you type in the chat just to me, what's the one thing you're most worried about for the test? Okay, the one thing you're most worried about for the test. Only one with these problems. That'll let me know when you guys are done.
I feel so. Come on.
I'm going to give you about 2 more minutes. It looks like I have some people done, but not everybody done. So I'm going to give you 2 more minutes. If you're stuck, I hope you're texting Bobby. So when you're done, type privately to me what you're most worried about the test. All right. So I know that a lot of you are worried about the test, and some of you feel like, oh, I don't know if I can do this. You know, this part, it's hard. So this is the hardest section, but that's why we're going to spend 2 days on this, okay? So don't let your anxiety get the best of you. If you've been practicing and doing your homework and following along and getting help when you need it, you're going to be fine. You have until Thursday to, you know, get that anxiety under control. So if you need to start studying today, that's a great strategy. Don't wait until tomorrow night to do that review sheet. Get it done. Okay, so I'm going to do the big reveal so you can see. Let's see if you got them right. We did the first 2, A and B. So now you have C, D, and E to do. So how many of you got part C correct? Let me know that you got part C correct. Yeah, Bree
I'm
did.
shocked that I got it right.
Oh, no, Maddie, you shouldn't be shocked. You've been working hard, right? Okay, who else got part C right? Does anyone need an explanation on part C? And there's 2 parts to this, right? First, you had to find the Z-score. Then you had to use the table.
I think I did see a hand up, right? In the video, did I see somebody raise their hand for, yeah. So yeah,
Cool.
if we could explain C a little bit, that might help
Okay.
some.
All right, so on C, I'm gonna go back to the previous slide so we can do it. So on C, we want the area to the left. So whatever our Z-score is, it's gonna be right on the table, right? Because the numbers on the table are to the left. So I'm gonna use the Z formula. I'm gonna do 128 minus 84.6, and I'm gonna divide by 19.1. When I do that on my calculator, I should get a value of 2.27. check that and make sure you get that on your calculator. I'm not doing that math by hand either. I'm doing it on my calculator too. Okay. So now I'm going to go to my Z table and I'm going to look up that 2.27. So I'm going to go back to a Z table. I'm going to go to 2.27. Now, I have between these two to pick from. I can either pick 2.2 or 2.3. And if I have 2.27, that is going to round to 2.3. So I'm going to use this value right here, this 0.9893. Questions on that? You okay? Did that clear it up for you?
Throw that thumb up if it made sense, or put it to the side if it was still a little confusing.
Yeah. Okay. I think you can only do up or down. I don't think you can do, I mean, if it's your actual thumb, you can do that to the side, but if it's not, then you'll have to think about that. Okay. Oh, this is interesting. I just got a little thing from Zoom that said now you can pin multiple people, which is nice. I don't know if you pin me as the speaker, but you could pin me and Bobby now. Oh, that would be exciting. Okay, so find the area to the right of 119.3. So first you find your Z-score, right? Using the same formula we just did, but this time you'll do 119.3 minus 84.6 and then divide by 19.1. That'll give you that Z-score of 1.82. This will be on that table. Why are we subtracting from 1 on this problem? Anyone know?
You said 100, right?
Yep, the 1 is 100, but yep. So I have the area to the left. I want to do the area to the right. So
Right. So you're wanting to deduct 1 because 1 equals 100, and we're talking about a percentage. So we're taking 90.96 from 100 because we're getting the percentage of the other side.
Excellent. And you should think about that. That's going to be a really small percentage, right? Because if you look right here, my 119.3 would be like here, right? And so my area to the left is going to be a big percentage, in this case, that 0.96. And my area to the right is going to be a small percentage, which is really that 0.0359. So if you use the picture to help you, it'll make a lot of sense. Now, this last one was a bit challenging. This last one, you had to find Z-scores for both of them. The Z-score for 80, which was this negative 0.24, and you had to find the Z-score for 90, which was 0.28. And since I have the area to the left, oops, I'm going to erase this so you can see this one because this one's important. So if we have 80 and 90, so if I start right here at my score of 80, that's going to be about right there. That's my X value of 80. And then if I have my X value of 90, that's going to be about right here-ish. So this is going to be my X of 90. Now remember, first, if I get my Z-score of 0.4013, that's telling me all of this area. Yeah. And then if I get my area for my second Z-score, I'm going to get all of this area. So to find out just this pink area right here in the middle, I'm going to have to subtract those two values. So if I take 0.6179 minus 0.4013, that's going to give me this 0.2166, and that's going to be this area right here. So if it says between, that's a little bit different. Oh, good question. Kate said, why did we use the Z-score of negative 0.25 instead of negative 0.20? So if you look at this one right here, negative 0.24, is that closer to negative 0.2, or is it closer to negative 0.25? Which one is it closer to? It's closer to this one. So that's what you're looking at. Okay.
I was rounding to the tenths and not the hundredths. Yeah.
Yeah, you have to be careful because you just want the closest z-score. So
And
rounding rules. There you go.
This is the first spot that you might have noticed on the chart that it actually does go past the tenths place value to the hundredths value.
Excellent. Now I know that last one was hard. The good news is tomorrow, this is all we're doing. You've learned everything now. We're just doing more practice of this. So you're good. And your exit ticket is here. And I can put it in the chat in just a second. So, and it shouldn't be too challenging. I didn't ask you anything. All you have to do is find a z-score on this one. So let me put it in the chat. You do have the QR code. And then you can go. I know today was kind of boring because it was all me talking instead of you, but tomorrow you'll get a lot more practice, okay? And we'll be in our groups tomorrow. Yes, intense. Sorry today was so intense. But this is not a huge portion of the test. If you look at your review sheet, you'll see it's just the very last part. So you'll be fine even if you can't, even if you miss this problem, you'll still be fine on the test. All right, I hope my no technology issues continue and have a great day. When you're done with the exit ticket, you can go.
All right, thank you guys. Bye.
Yep, bye, Andrew. Bye, Ulissa.
Bye. Thank you.
Later.
All right, I'm gonna go. Have a good one.
Bye.
Clementine, you need to get a, you need to reserve a time on Thursday at school with the lockdown browser. Tell them you need the lockdown browser at school. So why can't you download the lockdown browser? What system are you using? Ah, why did you not tell me that? I've asked like 60 million times if people have Chromebooks because Chromebooks don't work with it. So you need to see, let me see if we can schedule a time. Can you get to campus? Can you get to Southern and Dobson? Okay, so it would be Thursday during our class time. It would be at 9 o'clock. So you would have to get there early and make sure you check in. I will check on that today. Can you send me an email to let me know so I remember to check on that, because I'm going to go into another class and I'm going to forget. Okay. All right, cool. Send me an email and then we'll get it figured out. See you tomorrow. Bye. All right, let me stop my recording.